Recently, Sequoia convened leaders in AI for a day of conversations, demos, and talks. And Andrew Ng talked about AI agentic workflows, where he said a lot of really interesting things that we'll be taking a step-by-step look at later in this video. What does these revelations potentially mean for the tech dodge and the world at large? Stick around to find out. For those who don't know him, Andrew Ng is a tech genius. He launched the AI Fund in 2018, which was initially a $175 million investment fund for backing artificial intelligence startups. He is also the founder of Landing AI, which provides AI-powered SaaS products. Coupled with those, he is also the co-founder of Deep Learning AI and Coursera, where you can learn a bunch of different topics absolutely for free. In his demonstration at Sequoia, he talked about the large language models, LLM-based agents, which are basically non-agentic workflows. What this essentially means is that the non-agentic workflow doesn't do that much thinking, unlike the agentic workflow, which simply delivers remarkably better iterative workflows and results. One thing to also note is that agents are much more powerful. While they might technically be LLMs, agentic workflows have an upside, which is the fact that you can have multiple agents with different flows, all working together to execute a given task. Moving on, he also talked about the coding benchmark, Human Eval. The benchmark called the Human Eval was released by OpenAI a few years ago. Let's take a look at this demo. We have the GPT 3.5 and GPT-4, both with the zero-shot prompting. And what this zero-shot means is that you are basically promoting the LLM to carry out a task without necessarily giving it any chance to iterate. On the Human Eval benchmark, it got 48% correct. On GPT-4, 67% correct. But wrapped in an agentic workflow, the GPT 3.5 does better than the GPT-4. But if you also wrap the GPT-4 in an agentic workflow, it does great. This just goes to show how actually powerful the agentic workflow is. There has also been lots of speculation and words being tossed around about agents being the future of AIs. What do you think about this? Do you agree with people on this, or do you think otherwise? Let us know your thoughts down in the comments below. The broad design for agents is a very messy and chaotic space, because there's tons of frameworks like Autogen and TRUELY. For those who don't know, Autogen excels in creating conversational agents capable of working together. It lacks an inherent concept of a process. Orchestrating agent interactions in Autogen often requires additional programming, which can become complex as the scale of the task grows. While TRUELY is a role-based agent framework that allows users to customize agents according to specific roles, goals, and tools. This customization enhances problem-solving efficiency and facilitates task delegation among agents. Additionally, it also provides a flexible task management system where users can define tasks with customizable tools and assign them to agents dynamically. There's also tons of research and open source, so let's take a quick run through into each agentic reasoning design pattern so as to really get an idea of what's going on. But before we get into them, these 4 patterns will be capable of driving significant progress. And instead of having a large language model generate its final output directly, an agentic workflow will prompt the LLM multiple times, giving it plenty of opportunities to build step by step to higher quality output. At number 1, we have reflection, which is basically quick to implement. This tool reflects on the output, and this is pretty straightforward because of the name. But to sum it all up, it makes LLMs a lot better. Reflection is using one agent and giving it a prompt just to see fresh and better ideas. This can be a form of styling efficiency. To sum it up, reflection is a single coder agent. But at the same time, you can also have a critic agent, which is another LM which you can also give prompts. What this means is that the process involves prompting the model to generate a response, then asking it to reflect on its output, identify areas for improvement, and provide constructive criticism. The model is then prompted again, incorporating the feedback received to rewrite its output, leading to potentially better results. This self-reflection process can be applied to various tasks such as code generation, text writing, and answering questions, allowing the model to identify gaps and improve its performance. Beyond self-reflection, the model can also be equally equipped with tools to evaluate its output, such as running code through unit tests or searching the web for verification, further enhancing its ability to improve. Reflection can be implemented using a multi-agent framework, where one agent generates outputs and another agent provides constructive criticism, which can then foster discussion and lead to improved responses. Secondly, we have tool use. This is also as easy and straightforward as it sounds. It means you can use custom code tools. The LLM is given tools such as web search, code execution, or any other function to help it gather information, take action, or process data. The possibilities with the tool use are just endless. With tool use, you are giving the large language model code to use, and the codes are hard-coded, meaning no matter how many times, you'll always get the same answers. Both reflection and tool use are widely robust technologies. At number 3, we have planning. This is just giving the large language models the ability to think and plan through each step more carefully and calmly. It also prompts the chain of thought in large language models. The LLM comes up with and executes a multi-step plan to achieve a goal. For example, writing an outline for an essay, then doing online research, then writing a draft, and so on. And then finally, we have multi-agent collaboration. AutoGen enables the next-gen LLM applications with a generic multi-agent conversation framework. What this means is that it offers customizable agents that can integrate the large language models, tools as well as humans. Essentially, you can easily make them perform tasks autonomously. And with enough iteration, you get the best results, and you can also have different agents powering different models. Essentially, more than one AI agent works together, splitting up tasks and discussing and debating ideas to come up with better solutions than a single agent would. While planning and multi-agent collaborations are both emerging technologies. The downside to this is that you cannot always get them to work reliably, unlike the reflection and tool use, which work well and are more reliable. These design patterns enhance productivity and performance in AI systems, paving the way for more sophisticated and effective AI models. Agentic workflows have demonstrated potential in various areas like code generation, image manipulation, and planning algorithms. This goes to showcase the capability of AI agents to autonomously navigate tasks and adapt to challenges, indicating a bright future for AI advancements. When you have different agents and each is powered by different models which have been fine-tuned specifically for their tasks, then you get even better performance. The work that AI can do will expand dramatically because of agentic workflows. Agentic reasoning patterns are also going to be important because essentially, the set of tasks the AI will be able to do will expand drastically. Another thing to draw your attention to with these agentic AIs is the fact that there will be a lot of waiting around to get answers from the delegated tasks you have given the AI. It might take minutes or even hours to get a response. Another thing that we should also note is the fact that fast token generation by language models, LMs, is crucial in agented workflows for quick iterations. Andrew also mentions that reasoning and planning are top of mind. He also pointed out that agentic reasoning can lead to a series of drastic improvements on the existing models. So, what does this mean? With strong conviction, the AI agentic workflows have the potential to surpass the impact of foundational models in propelling AI advancements. And this could lead to unprecedented breakthroughs in AI technology. The idea of agentic reasoning and workflows is a significant development that could advance the field of artificial general intelligence, AGI. This represents a major advancement in the direction of increasingly sophisticated and intelligent AI systems. In conclusion, Andrew Ng's insights into the AI workflow reveal a sort of paradigm shift in AI development. The integration of agents by large language models coupled with agentic reasoning patterns holds the promise of potentially surpassing the existing AI models and propelling into the fields of mind-blowing breakthroughs. We've come to the end of today's videos. Let us know your thoughts down in the comments below. Don't forget to subscribe to our channel and hit that notification bell to get up to date on fresh content.